Good afternoon, ladies and gentlemen. Good evening, South Asian friends, and good morning, American and European friends. I welcome you all for today's e-conference on non-intrusive flow measurement and process analytic solutions in chemical plants, organized by Indian Chemical News, the most credible online media platform for chemicals, petrochemicals, energy, and pharmaceuticals, and supported by Flexsim. Myself, Praveen Prashant, editor Indian Chemical News, will be your host and moderator for today's conference. Next slide. Today, we have got eminent speakers from different industry who will talk about flow measurement and process analytic solutions. Let me introduce you to the speakers for today's e-conference. We have Mr. R.S. Rajan, Senior Vice President, Manufacturing, Make Money Fine Chem Limited. Mr. Vivek Gupta, Joint VP, Instrumentation and Digitalization, DCM Sriram Limited. Mr. Mahesh Patil, General Manager, Instrumentation, Deepak Fertilizers and Petrochemicals Corporation Limited. Mr. Vinod Patil, General Manager, Electrical, Instrumentation and Civil, Aarti Industries Limited. Mr. Kanji Kumar Wadia, Senior Engineer, Instrumentation, Naveen Fluorine Instrumentation Limited. Dr. Ingo Nickel, Head of Market Management for Chemical Industry, Flexsim GmbH. Mr. Matthias Gale, Global Analytics Sales Manager, Flexsim GmbH. Next slide. The key discussion points are problems catering to flow measurement and process analytic solutions in chemical plants. Flow measurement solutions ideal for explosive and hazardous liquids in chemical plants. Advantages of clamp-on ultrasonic flow metering and concentration measurement solution. Reduction in OPEX and CAPEX with deployment of clamp-on ultrasonic flow metering solution. And how does ultrasonic flow metering solution increase safety and security for chemical manufacturers? Energy savings due to clamp-on ultrasonic flow metering solution. Next slide. To engage the audience in the e-conference, we have introduced ICM Play and Win contest. Just briefing you about the contest. I will be asking you questions from the audience during the course of the session, and the one who responds first with the correct answer stands eligible for winning rupees 1,000 gift voucher from Amazon. All the questions will be asked by me, and replies need to be given in the chat window. I would like to stress that please give your replies on the chat window, which is at the bottom of the Zoom screen. Final winners will be announced at the close of the e-conference, that is today, Thursday, on 16th September at 4:30 p.m. Indian Standard Time. Terms and conditions: only the person with the correct answer responding first in order of priority shall be declared winner. Organizer and sponsor partner employees are not eligible to participate in the contest. Organizer decision to be treated as final in case of any discrepancies. Gift vouchers to be sent electronically to all the winners post completion of the session. So this is our upcoming e-conference, Nextgen Chemicals and Petrochemicals Summit 2021. And the topic, the main theme for the summit is moving in the big league. This is a virtual summit, and we are doing it on October 7 and 8, 2021. Next slide. Next slide, please. So if you see the key thematic sessions that we are having is policy changes to make Indian chemical industry globally attractive, digitalization in industry 4.0, accelerating its pace, Indian CMSR technical session, petrochemicals driving sustainable growth, specialty chemicals expanding its horizon, sustainability earlier the better, pharmaceuticals strengthening correlation between chemical and pharmaceutical, agrochemicals doubling India exports / farmers income, hydrogen the next clean energy. So I would request everybody to please register yourself as a delegate for this e-conference and for this summit. And these are our partners whom we have signed. Next slide. So before we start the panel discussion, let me ask Dr. Ingo Nickel, Head of Market Management for Chemical Industry, Flexsim GmbH, to give his presentation. So over to Dr. Ingo Nickel, and he's going to present on flow measurement in hazardous areas. I request Saurabh to please provide sharing screen to Dr. Ingo Nickel.
Okay, thank you, Praveen. I hope you can hear me.
Yeah, we can hear you, sir.
Great, thank you. Yeah, it's a great pleasure for me to join this e-conference, and I think it's a great format for presenting some interesting topics for the chemical industry. I'm also thank all the panelists for joining, and I think it will be a very fruitful discussion. And also I welcome all the attendees here to join this very interesting e-conference. Yeah, my name is Ingo Nickel. I'm the head of the market management here at Flexsim and responsible for the chemical industry. And due to this, I'm responsible for all products and all applications which we are facing in the chemical industry with our products. And today I want to give you an introduction to our technology and the challenges in the chemical applications for flow measurement. But before I want to give you a rough or short overview about our company. Some words about Flexsim. Flexsim has been developing, building, and selling non-invasive measurement technology since 1990. The company was founded as a startup in Berlin by 4 students from the University, and they choose the name Flexsim as an abbreviation for flexible industrial measurement, or in German, flexible Industriemesstechnik. The founders have been active in our research department for over 30 years, and they drive the development of the company and our products. Over the time, Flexsim has grown from a four-man startup company to a globally active medium-sized companies with several subsidiaries worldwide. And nowadays we have more than 500 employees. And Flexsim is the technology leader for non-invasive ultrasonic flow measurement and the pioneer in this field. And for measuring of any kind of gas, liquids, and also of steam. And today I want to give you a rough overview about the measuring capabilities we have within the chemical industry. What are the advantages of using a clamp-on ultrasonic flow measurement system? And why it's interesting for the chemical industry? Because it has several advantages which can increase tremendously the security for operators and for plants. Ultrasonic flow meters can be used for very dangerous, corrosive, and abrasive media. It can be also used for very high temperature applications, but also for cryogenic media. And also a very important point, which I will figure out later on, it's also a very reliable solution for very high pressure applications like the LDP process. Furthermore, ultrasonic flow meter can help reducing costs. I think it's nowadays for all of us important to reduce the energy consumption. And by using ultrasonic flow meters, we can reduce because we installing a system which generate no additional pressure loss. This means if we do not lose any kind of power of our pumps due to the fact that we inserting any kind of device into the pipe. And if we are working with corrosive media, the non-invasive approach removes the need for cost-expensive alloys or other expensive material for the wetted parts. And also a very important point, if you take a look on the total cost of ownership of a flow meter, then it's always the first point to see what is the price of the device, but not all people are looking for the complete cost over the lifetime of the product. And the ultrasonic flow measurement equipment, they are almost maintenance-free. This means you have an initial cost for purchasing this device, but at the end, you have no additional cost in the future for maintaining. I think the reliability and high plant availability are very important aspects for plant and unit operators. And why is the ultrasonic flow measurement a highly reliable measuring solution for chemical plants? There are no wetted parts which can be affected by the media or the fluid. This means corrosion or any kind of deposit formation on the sensor cannot affect the measurement, and there's no risk for clogging in the pipe. Furthermore, the design allows the metering at very low flow rates and provide a completely drift-free measurement, which is also unique compared to other flow measurement technologies. And yeah, maximum plant availability is guaranteed because the installation can be performed without any process interruption. And during the startup, a portable flow meter can check the media flow. In operation, the media flow can be checked at different positions in the unit. And also a very important point, ultrasonic clamp-on flow meters are a retrofittable solution, which allows an easy exchange of measuring equipment in existing plants. Yeah, for all of you who are not already familiar with this technology, I want to try to explain the measuring principle. Yeah, in principle, it's a simple transit time measurement, what we are doing with our equipment. We have two sensors, at least two sensors, and these are mounted on the pipe, transducer 1 and transducer 2. And these sensors send ultrasonic pulses through the fluid, and both transducers act alternatively as transmitter and a receiver. And due to the moving fluid, the signal which flows in flow direction will be accelerated, and the signal against the flow will be slowed down. And the time difference between both signals is direct proportional to the flow velocity. And by multiplying the flow velocity with the cross-section area of the pipe, we can determine the volumetric flow. Yeah, in this picture you can see clamp-on technology is not it is a very reliable and robust measuring equipment. As you can see, our equipment is fixed, very robust on the pipe. We have special straps. We have a housing for our sensors, and this avoids to come to get any contact with rain or other condensed water. And so our sensors are fully secured with this additional housing. And if we take a deeper look into this housing, then you see how the transducers, the two transducers, are mounted on the pipe. They are fixed with coupling pads mounted on the pipe. There's it's a very robust fixation, and without any risk of moving of the transducers. It's a very robust mounting solution. If you are coming into the chemical plants, what are here the typical challenges for flow measurement? And principally, we have three main challenges. We can have high pressure, we can have high temperature, but also corrosive media can be critical points for selecting a suitable flow measurement solution for the production plant. Particularly metering fluids at high pressure can be a very demanding task for all components. To fulfill required pressure ratings of the unit, process equipment can be expensive if they are in contact with the media. If ultra-high pressure ratings are required for LDPE plants, for example, it is almost impossible to find a suitable inline flow meter. Temperatures are also a different important point to consider. You can have cryogenic temperatures below -150 degrees Celsius, but also if you go into refineries, then you have also very high temperatures up to 600 degrees Celsius. And these are, of course, very challenging conditions for inline flow measurement equipment. The third part are corrosive media. If the media is highly corrosive, like sulfuric acid, hydrochloric acid, nitric acid, or other corrosive media, the selection of the wetted part or the wetted material is very important. And for high corrosive medias, you have to select between expensive MOCs like Castelloy or tantalum, but Flexsim's approach of having non-intrusive flow measurement solutions, we are completely independent from these demanding conditions. and all critical conditions can be covered perfectly with our clamp-on flow meters. I want to give you some details or some examples for these different challenges when critical or environmentally hazardous, toxic or flammable fluids needs to be reliably conveyed or metered in high pressure processes. Flow measurement can be a big challenge. Pressure rated flow meters are limited available, particularly at very high or ultra high pressure. And the non-invasive flow measurement is completely independent from the existing process pressure. And so it's the perfect solution for those processes. A lot of hydro processing processes in petrochemical plants runs at elevated pressure conditions. Hydrogen is used in several applications for cracking or desulfuration tasks. But a very nice or very impressive example, which we have in our database, in our application database, are the extreme conditions which can be found in LEP plants, where we have hypercompressed ethylene at above 1,500 to 3,000 bar to produce low density polyethylene. And particularly this example shows the extraordinary measuring capabilities of a non-intrusive flow measurement equipment. And here I summarized some, or in the next slides, summarize the typical process conditions. The LDPE process, or the producing low density polyethylene, is one of the most challenging processes within the chemical industry. For the production of LDPE, the ethylene must be compressed in several stages to final working pressure of around 3,000 bar. And at this pressure, ethylene can react with an initiator to form a polyethylene. And by changing the process conditions, the final polymer properties can be adjusted. And on the right bottom, you see a picture, and this is a typical stainless steel pipe, which is used in LDPE reactors. What you can see, we have an extreme wall thickness, which is required to withstand pressure up to 3,000 bar. And typical inline flow measurement equipment cannot be used because they have not the required pressure ratings. And we have several references where we're using our equipment for these very demanding conditions. And here I summarized the general application details for typical process conditions within LDPE plants. And our technology can cover several ultra high pressure measuring points in the production units of LDPE. As I mentioned, that the ethylene must be compressed up to 3,000 bar. And under these conditions, the ethylene is in a supercritical phase. For these demanding conditions, inline flow measurement equipment is not available or very, very expensive to fulfill the required pressure rating. Furthermore, this must be also taken into account for LDPE plant operators. To implement an inline flow meter can cause an additional source of vibration, which should be strongly avoided to reduce the risk of damage of the entire plant or the used hypercompressors. They are quite expensive units, and this to have an additional source of vibration is quite critical for LDPE plants. But if you're using a non-invasive approach, this is completely, and we have no pipes must be opened or removed. We have a minimal installation effort, and this results in no additional cost to accommodate this required high pressure rating if you're using a clamp-on flow meter. Furthermore, it's also important our measurement or the measurement of the ultrasonic flow clamp-on flow meters are completely unaffected by vibration or wax particles. Wax particles can have a significant impact for other flow measurement technology, and also a drift of measurement values by variation of the static pressure cannot be observed with the clamp-on flow meter solution from us. Another very important important challenge within chemical applications or chemical plants are corrosive media. And they are always critical points in the selection of a suitable material of construction for the process equipment. And particularly inline measurement equipment are crucial points. But if you're using clamp-on ultrasonic flow meters, they are coming not in contact with the media, and this avoids the selection of expensive materials for the better parts. And a very good example is the metering of sulfuric acid. And we have a lot of plants equipped with our flow meters for the sulfuric acid production with our clamp-on flow meters. Also important process within the chemical industry is, of course, the chloralkali process. And here we have also a lot of measuring points, or where we have to are coming in contact with corrosive media, with high concentrated acids, or for example caustic soda. And here for monitoring the complete process, not the flow measurement can be interesting. Moreover, it's more important to monitor the mass flow or the concentration of the used acids and produce chemicals. And also with our equipment, we are able to measure the concentration. And for example, we are using one of our so-called PIOX system to measure the supply of the raw brine, as well as the in and out flow of the treated brine in the chloralkali process. On the other end of the electrolyzer, the instrument is most adapted to measure sodium or the caustic soda in all its concentration through the whole evaporation process. And when it comes to other core processes within the chloralkali process, chlorine gas treatment, the main application is here to measure the sulfuric acid for the chlorine gas drying, as well of the mass flow measurement of the liquid chlorine. And here you can see we are coming in contact with sulfuric acid, with caustic soda, very aggressive media. And if you have a measurement solution which is completely non-invasive, then it's a big advantage. Here's some details about sulfuric acid flow measurement. I think sulfuric acid is the most important, or is the key substance in the chemical industry. It's most commonly used in fertilizer manufacture, but also important in mineral processing and oil refining. And we have our flow meters can be used for just the volume flow measurement, but also for mass flow measurement of highly concentrated sulfuric acid, and also for concentration ranges of 80 to 100% sulfuric acid. Our system can be used, but also we can cover oleum with our flow meters. Another challenge are temperatures. We can have cryogenic temperatures within chemical plants for cooling applications. This means, temperatures below -150 degrees Celsius, but also high temperatures up to 600 degrees Celsius are very challenging conditions for inline flow instrumentation. And we have also solution for this range of temperature, and we have special mounting systems which are able to provide also a clamp-on flow measurement under these demanding conditions. We have all of our sensors can be equipped with a patented design thermal decoupling element to achieve a very reliable flow measurement also for extreme temperature conditions. Depending on the process or the chemical reaction, heat must be transferred within parts in the plant. Some chemical reactions or processes need additional energy to run effectively. On the other hand, exothermic reactions requires an effective energy management system to remove excess heat from the process to avoid critical situations. Heat can be transferred by heat transfer oil, steam, or cooling fluid within chemical plants. And typical measuring tasks are monitoring of steam flow, heat transfer oils, and cooling liquids. And as I mentioned, we have a dedicated mounting system, which can be used for extreme low, but also extreme high temperature. It's called the wave injector. And the wave injector, along with the ultrasonic transducers, is simply installed on the outer surface of the pipe using some coupling plates for proper acoustic contact. And this means we have also a very, very sophisticated solution for very extreme temperatures. And here you can see it's a cooling application at Dow. You see the pipe, it's completely with ice covered due to the low temperature. And this is a typical heat transfer application, which you have found in the process of the production of MDI, of an isocyanate. And during the purification of this MDI, heat must be dissipated from the process. And for this, an organic coolant, which is cooled down to -40°C, is used as a heat transfer medium. And together with our wave injector, we can also providing a solution for this very challenging low temperature. Another very important point, steam measurement. Flexsim launched 2 years ago the first clamp-on steam flow meter. This means we are able to measure steam, low temperature steam, but also high temperature steam without opening the pipe and then introducing any kind of equipment into the system. Why steam so important? Steam contains a tremendous amount of energy. It is produced from water, and steam is commonly used in the chemical process industry for process heating, power generation, but also for cleaning tasks. And measuring steam flow is very challenging and can be a very cost-intensive measuring task for inline meters if the pipe size is larger than DN 150, because then the vortex flow meters are quite expensive, and also other technologies. But with a clamp-on flow meter, if you're able to measure the steam without opening the pipe, it's quite nice. Yeah, we are having solutions for low temperature and high temperature steam. There we have different measuring principles to cover the low temperature steam area, but also the high temperature, the superheated steam area. And here you can see the overview, and you see the difference in transit time in the CFM. CFM is the mode for the high temperature steam. And with the CFM mode, we can reach applications for superheated steam up to 600°C. Yeah, the Fluxus range of flow meters measures the volume, mass flow of liquids and gases, and concentration, density, non-intrusively with our proven clamp-on transit time correlation technology. And yeah, as I've showed you, the transducers are simply clamped on to the outside of the pipe and never get in direct contact with the media, which is flowing inside the pipe. And here you see some products which are important for chemical applications. We have so-called 7 series. We recently launched the 8 series, 831 series, which is particularly used for ATEX Zone 1 environments with intrinsically safe inputs. Then we have a wave injector for high and low temperature applications. We have a PIOX system. It's a refractive index and process analyzer, and also a clamp-on solution called PIOX-S for mass flow and concentration measurement. At the end, you see here an overview about the application range. We can covering very small pipe diameters, but also can go up to 6,500 millimeters pipe sizes. In principle, all kind of pipe materials are can be covered with our equipment, and on the temperature range, we are can cover with our wave injector applications from -190°C up to approximately +600°C. Yeah, at the end, I want to sum up the advantages. As the transducers are clamped on to the outside of the pipe, the measurement system is not exposed to any wear, tear, or abrasion from the medium flowing inside the pipe, and thus very reliable and durable. Installation requirements are non-existing. No cutting or welding has to be done to the pipe. Costly process shutdowns are completely avoided with a clamp-on solution. Yeah, moreover, the measurement system does not cause any pressure loss, which is at the end and which in the end avoids unnecessary energy cost involved to the customer. Measuring at very low but also very high pressures, thick pipe walls and exotic materials, as well as badly manufactured pipes, is not a challenge for a clamp-on flow meter from Flexsim. Also, we are supporting, of course, a lot of process interfaces like Profibus, Foundation Fieldbus, HART, and also we are covering all explosion-proof environments, ATIX, Zone 1, Zone 2, FM Class 1, Div 1, Div 2 environments, and so we have a complete package for flow measurement equipment within chemical plants. I'm now at the end. I think we will have later on more time for questions, and then I want to hand over to Praveen again.
Thank you, Dr. Ingo Nickel. You have talked about the pipe sizes, you have talked about the temperature part of it, and you have also talked about the flow velocity, and I see a lot of questions on the chat window as well as Q&A window. I request all delegates to please type their questions on the chat window, in the Q&A window rather than on the chat window, so that we can take it up, all the questions at the end of the panel discussion. Before I open it up for a panel discussion, let me warm up and start with IC and play and win contest. So I request all delegates to please type in their answers in the chat window. So those who are participating, please type your answers in the chat window. And my first question to you is, where is Flexsim headquarter located? Where is Flexsim headquarter located? And let me, I think I see a lot of correct answers. Let me ask the second question also. And I see the screen now being stagnant. I'm talking about the chat window. What is the meaning of Flexsim? This is the second question. So I request all delegates to type in their answers. What is the meaning of Flexsim? Dr. Ingo Nickel talked about it during his presentation. So I request you to please type in your answers. In the meanwhile, our delegates will keep on typing the questions. Let me open the panel discussion. I would request, sir, to please restrict you, because we have already at around 3:35 we have. So keeping that into view, I would request, sir, all our speakers to be precise and concise, and would request if you can keep your speech for 2.5 minutes each, sir. So to start with, we have 3 tracks. One is on challenges. The second is on field performance and applications. And the third track is on maintenance, replacement, and accuracy. And majority of the questions which are there in the Q&A window will be answered through the panel discussion that we are starting. Let me ask Mr. Mahesh Patil, General Manager, Instrumentation, Deepak Fertilizers and Petrochemical Corporation Limited. And I have 2 questions for him in the first track. What are the key challenges that chemical plants face with regard to the flow measurement and process analytic solutions? And where do you see the fit or advantage of clamp-on ultrasonic flow metering and concentration measurement solution? So over to Mr. Mahesh Patil.
Good afternoon all. Actually, the major flow challenges which are faced are like flow volumes and pipe sizes, because large flow volumes are difficult to quantify. Then lack of straight pipe runs in available piping system is the another challenge. Then ability to retrofit the meters into existing piping with minimal disruption, or we can say hot work requirements or any other modifications and changes. So that should be minimal. So this is again one challenge. Fluid fluid which contains particulates can cause noise that interfere with the flow measurement, and which leads to inaccurate flow measurement. Then the fluid which are abrasive, aggressive or toxic, chemically aggressive, that can subject the flow instrument to wear and tear. So that is another challenge while measuring flow. Two-phase flow, or we can say entrained air in a liquid, is the another challenge in measurement of flow, because the flow will be erratic at certain time when such condition occurs during flow measurement. Then another point of consideration is like when liquid or fluid contains any coating phenomena, or we can say it has the characteristics of coating type phenomena. So that can result in deposition of that chemical over the flow measurement electrodes in case of magnetic flow meters, and this can result in erratic flow reading and even the malfunction of flow meters. And with respect to these challenges which we have discussed, ultrasonic flow meter have some advantages over this, like since it is non-contacting type flow meter, then it can be used for aggressive or corrosive chemicals flow measurement. And since it is installed outside, or we can say it's a non-intrusive technology, so there is a very minimal interruptions in process, because hot work or any cutting work is not required as such in process, and moreover process shutdown is not required. We can install it online, so that will be a great advantage. Another one is since it is not inline type of flow meter, so obstruction will be not there, which will result in pressure loss and later on the recovery of that pressure. So these are some of the benefits with ultrasonic type of flow meters to overcome the challenges which are normally faced in other type of flow meters. Yeah, that's all from my side.
Thank you, Mahesh sir. Now let me come back to Mr. R.S. Rajan. He is Senior Vice President Manufacturing, Make Money Fine Chem Limited. And my question to him would be challenges faced by Make Money Fine Chem in superheated steam, low pressure gas applications, and dual phase medium flow measurements. And my second question to him would be flow measurement and process analytics solution. No, the second would be in the present scenario, how are you overcoming it? So over to Mr. R.S. Rajan. And your 2.5 minutes start, sir.
Good afternoon. It's at present Make Money Fine Chem. We are having a installed capacity of 96 megawatt captive power plant, and total steam generation is of 470 tons per hour. And it is in all this, the steam parameter is of 110 kg per centimeter square pressure and 535 degrees centigrade temperature. What we are extracting, it is going to the different plants. For like the downward plant, it's a caustic soda plant, caustic potash, hydrogen peroxide, chloromethane, etc. As we consider some of caustic soda plant is a totally power intensive plant, which is undergoing electrolysis process. This monitoring of every part of this on steam, we have to quantify it. But as it is a very, in order to, as the 100% steam is passing through the turbine, it is highly essential to monitor the steam consumption. In order to keep the minimum generation cost, the plant-wise losses are to be avoided. during the initial process, on all the turbine inlets are provided the orifice flow measurement, orifice plate flow measurement. And because of the frequent leakage through the gasket, we have to stop the plant and we have to replace it, or either waiting for the shutdown, or we have to stop the plant to replace the gasket. It needs maintenance as well as downtime of the plant. Then we have decided to go for it's a flow meter of this one. It's a flow nozzle type, which that we have changed it as a flow nozzle. We replaced the orifice plate with the flow nozzle. So initially we have faced a little problem because there was erratic reading. When there is some fouling in the flow nozzle passage, we face some fouling. But later on, we have made it sure that's all. Before we have thoroughly flushing the flow nozzle, and we have put the plant in operation. And this flow nozzle, we have noticed it is more accurate than the orifice plate. Because moreover, we have taken a special care when the plant is being during the time of commissioning. We ensure thorough steam blowing of the entire pipeline and boilers, and thorough steam blowing we are carried out, and flow nozzles are installed after the target plate is totally cleared. That is we're taken for that. Moreover, in order to avoid any deposit on the flow nozzle, we have maintained the best quality DM water, and water quality is thoroughly maintained so that no sticking on the flow nozzle, so that we could able to maintain this. And regarding this, you are talking about the hydrogen, what the low pressure hydrogen gas at low pressure, that's around 200 millimeter of water column, is used to produce hydrochloric acid in the hydrochloric HCl furnace. For the low pressure gas, it is a dual phase application. That's got the gas coming from the electrolyzer. It is having gas plus moisture. Also we are using differential pressure flow meter with orifice plate. Due to the accumulation of condensate on the lines as well as in the impulse line, flow meter is used to show erratic readings. Based on the operational experience, whenever we feel there is a deviation in the flow meter reading, we flush the flow measurement system and cross-check the flow readings with the process back calculations, which confirms the satisfactory working of the flow meter. The third question you asked about the dual media, high temperature, because we are having another area, this in the flaker unit. It's a molten salt is a mixture of 3 different salts named NO3, NaNO2, and NaNO3. The melting temperature of the molten salt is ranging from 140 degrees centigrade to 160 degrees centigrade, depending on the composition of the mixed salts. This molten salt is used to as a heating media to increase the concentration of the caustic soda from 50% concentration to 99.5% concentration. So 99 is almost like a flakes. The operating temperature of this molten salt during heating is approximately 410 degrees centigrade. In the application of molten salt, we are monitoring temperature at a different place. The present scenario, what we are doing, as it is a direct measurement is not possible. We are measuring the temperature at different places using thermocouples. With the help of temperature reading and final product concentration, the flow of molten salt is estimated. It is a back calculation. We are also in the process of getting a suitable flow meter for direct measurement and to perform at a high temperature and to properly solidify the low temperature. These are the things we are facing the problem in some.
Thank you, Mr. Rajan. Now let me come back to Mr. Kanji Kumar Wadia, Senior Manager in Instrumentation, Naveen Fluorine International Limited. And he's going to talk about the key trends and technologies in flow measurement and process analytic solutions and the challenges faced by Naveen Fluorine. Kanji Kumar Wadia, sir, if you can switch on your video so that we can have a look at you. And your time starts now, sir.
Good afternoon, everybody. Sorry, I don't have the video facility available over here.
No problem,
So
sir.
sorry
Please go
for
ahead.
that. Yeah. As Mr. Mahesh Patil sir has already given many answers on the presently going challenges for the flow measurement and process analytics. Only I would like to add some of the things to with it that clamp-on meter is having very much benefits for the very large pipeline sizes where its cost and everything is also very low. And for inline flow meters, we have many of the abrasive, corrosive, erosive, and contact types meters. But in clamp-on meter, we can minimize the direct touch of the metals as well as contact parts of flow meters with the process fluid. So with this, we can do any type of maintenance at any time if required. We can do any of the installation of the flow meter at any time required. Just only thing we need to check is some of the pipeline upstream, downstream requirements, if any, and vibration like things, if any. And in Naveen Fluorine, we have many types of products and many types of raw materials we have been using. But our main challenge is with the HF concentration. We are handling the HF fluid and we are also diluting this HF fluid for various uses in pharmaceuticals and agricultural products. So while diluting, we need to take many of the samples that whether the concentration has reached 50%, 40%, 30% or not. And this diluted hydrofluoric acid is very corrosive and it is very poisonous and it is very much, it can create fatal incident also if we don't wear the proper suits. So sampling of it has been reduced by installing this type of flow meters and our reliability is also very good. So I would sum up with this only.
Thank you, sir. I think you are posing a lot of questions to people from Flexsim, and once we listen from Mr. Vinod Patil and Vivek Gupta, we will come back to Flexsim and know how are they, whatever the challenges that you talked about, how are they being tackled by them.
Okay, thank you, ma'am.
Thank you, sir. Thank you. So now I come to Mr. Vinod Patil, General Manager, Electrical Instrumentation and Civil Aarti Industries Limited. And my two questions to him would be, what are the key challenges that chemical plant face with regards to flow measurement and process analytic solutions? And where do you see the fit or advantage of clamp-on, ultrasonic, flow metering and concentration measurement solution? So over to Vinod Patil ji. And I would request, sir, if you can limit yourself to 2.5 minutes.
Sure. So I'll not repeat again. Yeah. Thank you, Prashant.
Thank you.
And my co-panelists have already shared about the challenges, but I will share with you all. The key challenges are basically the selection of MOC. MOC is a vital for that is material of construction for particular specific instrument or device. And second, the application is inline. So these are the major challenges. If we install the inline instrument, the maintenance is again new challenge for the maintaining the system, installed systems. So to overcome all the challenges, so there are the solutions available, but every solution there has its own pros and cons. So if we install the inline devices, so it has the maintenance feasibility, and in running operations, we have to shut down the plants. So a lot of safety precautions. Nowadays, all the industries are very cautious about the sustainability and safety. We at Aarti, we are following the best safety practices. So there are the challenges for the maintenance also for the inline instruments. So to overcome all these, the MOC challenge, then the installation challenge, maintenance challenge. So there are the solutions, and we at our Aarti, we are already installed the devices for the to overcome these challenges. So basically for the measurement of SO3 and concentration. So we have already installed the non-contact flow meters, and so by installing this, we already overcome all the challenges. Yeah, Prashant.
Thank you, sir. We will come back to you with the second and the third track.
Sure. Sure.
Let me ask our learned Mr. Vivek Gupta ji. And he is the Joint VP Instrumentation and Digitalization, DCM Sriram Limited. Sir, wanted to know from you the key trends and technologies in terms of flow measurement and process analytics solution, and what is the present usage in your organization, sir? So over to Mr. Vivek Gupta ji.
Thank you, Indian Chemical News, for giving me these opportunities, and thanks to my co-panelist giving a good insight. As you are asking about the key trends, so let me tell you, today everything is getting virtual. So from inline, we have come to online. And that is where the things come, that instead of putting a measurement sensor inside the pipeline, and that the challenges are well known, as all of my co-panelists have already informed to you. So I feel that the key trend is to get a kind of measurement for which we need not to stop the plant, we need not to do any kind of piping work, we need not to do any kind of retrofitting. And what I feel the major trends is the digital signals for the flow meters, the multiple measurement formats, online diagnostics, troubleshooting, remote calibration and configuration, and smart sensors with online alerts. These all things, if all of us can recall, this was the need of the hour, specifically during the COVID times. Had we got such kind of measurements in our plants, which were perhaps not available or which were extremely needed when the manpower was quite optimized. So this is where the clamp-on type flow meter will play an active role. And specifically, we know that when we go for a measurement kind of a thing where we have to take a sample, means if we have to do orifice plate, then you have to have the low pressure and high pressure side tappings. There are chances of the choking. So the another thing which is a key trend is the automated cleaning. How do we get that automatic cleaning kind of a concept so that these measurements are true? See, one more thing is there, instrumentation earlier used to be only for the kind of measurement or the monitoring, but the time has changed now. Instrumentation is giving an opportunity to the process people, to the plant, to the senior management to take a call and a decision-taking mode. At DCM Sriram, as you have asked me, what are the kind of instrumentation we have? So let me tell you, DCM Sriram Kota complex has got 8 plants, and I think we have all kind of measurements which are available on the earth for the flow, right? From the primary DP type of transmitter where we use orifice plate, we have magnetic flow meters, we have Coriolis flow meters, we have open channel level-based flow measurement, we have pitot tubes, and we have magnetic flow meters, and then other kind of flow meters also are available with us. And as far as the clamp-on type is concerned, we do not have much, but as our webinar progresses, we will talk more about this. But let me just tell you, flow measurement is very, very vital as far as the custody transfer is there. Because in our Kota, it is an integrated complex. So there are steam which is given by a power plant to various consuming plants. There it's very important, and that the flow measurement plays a vital role. I was just going through some of the world articles where the survey is done, and it's found that the global flow meter markets are growing with a CAGR of 6.43%. And that's quite a good figure. So it means everything should be in flow. If we know if anything gets clogged, even our blood also gets clogged, we have a kind of an attack. If the water gets clogged, we have a lot of issues. We know diseases are spread. So everything should flow, and flow measurement should be perfect enough so that the plants run smoothly. Thank you, Praveen.
Thank you, Vivek ji. Good to know that. And I was listening to Dr. Ingo Nickel, and I saw that there is no obstruction. All the transducers and all the clamp-on is outside the pipe. So no obstruction, and it is just like a bypass that you are doing of a heart rather than putting something inside the heart. So keeping that into view, now we are at the end of the challenge track, and let me get the views of Flexsim, and we have Mr. Matthias Gale. So my question to him would be, there were some interesting questions about use for HF fluid, MOC. These are definitely there, but I would like to ask you, given the trends and challenges in terms of flow measurement and process analytic solutions, how do you see the fit or advantage of clamp-on, ultrasonic flow metering and concentration measurement solution? And what would be your advice to the chemical industry based on whatever feedback that they have given to you? So over to Mr. Matthias.
Yeah, thank you a lot. Thank you for having me, and thank you for all the interesting participation so far. I think my predecessors, they already talked a lot about like the particular challenges in the factory and so on, and I would like to add like the vision a bit more from the global perspective, because now in Corona we are participating on this kind of conferences like all around the world, sulfuric acid conferences, fertilizer conferences, and so forth, and there are basically two big themes emerging that are driving the decision makers, right? One of is that Mr. Gupta mentioned in his speech as well, is the topic big data, right? Everything has to go digital. Everything needs big data to optimize factories, to make everything more efficient. But to make big data happening, it actually needs data. And so the very big trend is measure more, measure more, measure more. Put measurements, be it flow, be it analytic, also simple stuff like temperature and pressure into lines where you have not done it before. If we are continuing down this trend, then the question is, how can we do this in an effective way? And clamp-on is a big help here because, as everybody mentioned already, it's so easy to install, right? You don't have to shut down the factory. You can just simply go and install it on your pipe as you're running your factory as normal. So this is one big trend here, and that's where clamp-on is of a huge advantage. And the other point is obviously climate change. Now, I think how climate change is going to affect the industry really depends on your particular country. Like if we look here in Germany, obviously rising costs in energy is a huge topic. I think this year they went up like by 8 to 9% already. But also in countries where the government is not increasing artificially the energy costs, we're going to face demands of our customers asking, what's your CO2 footprint, right? And in order for you to know what your CO2 footprint is for that particular chemical that you then provide to, let's say, a car manufacturer, or that you provide to a farmer that then works for Nestle, whatever way around, they're going to ask, what's your CO2 footprint? And to know your CO2 footprint, you need to know where's your energy used. So how do we use energy? We use it by steam to heat, or by cooling water or other cooling liquids. And then that means, again, we need to upgrade surveillance, control of those systems to see where is our energy actually flowing. And sometimes you don't even want, you have so many lines, you don't even want to know, like, it's not feasible to install flow meters in every line because that's just too expensive. And I think clamp-on also helps there a lot, because there's the opportunity of portable clamp-on meters, right? Where you go like, okay, I have this 20, this 50 cooling water lines, and I want to optimize them. And I buy a clamp-on meter and go from one line to the next line, and can alternate the meter. So it's actually also helping you to have a cost-efficient solution for the climate change challenge. So I think, given the shortness of time we have, these are my my two big top challenges. And then I saw there were a lot of very particular questions coming in the Q&A. I think we're going to talk about this then in the end to round up.
Thank you, Matthias. I see around 25 questions already being posted, some also on the chat window. So my request to the panelists for the second and the third session is, I will have to reduce my time from 2.5 minutes to 2 minutes, because even Matthias has to give a small presentation. So keeping that into view, I request all my speakers to be precise, talk for 2 minutes, because I have to do justice with the delegates also. And with this new technology coming into forefront, there are many questions which needs to be answered. And it has to be answered by all of you together as a team. So now I come to the second track, and the second track focuses on field performance and applications. And I'm just reversing the order for all speakers. So I would request now Kanji Kumar Wadia ji, Senior Manager Instrumentation Naveen Flory. And my question to him is, you have installed a clamp on the HF concentration monitor more than two years ago.
Yes, sir. We have installed a Flexsim meter for more than 2 years ago. Previously also we were having contact type HF concentration meter of different company, and it is inline meter. We are not able to give any justification to our production people whether it is working okay or not right now when they have any issues, because we have to take it out and we have to check it. So we need, since HF concentration 30 to 40%, and we are going with 20% also concentration and 50% concentration also, which is very much poisonous. And it is almost like a fatal accident. With the installation of this meter, we have reduced our reliability, and repeatability of the readings also. Starting time we have to do some of the samples to check the accuracy of the meter, but after that now we are completely in line with the meters, and we are having good reliability, repeatability. We are not having any blips also, and we have, to be really saying, we have reduced our sampling frequency. So this meter has really helped us in saving people, human beings also. Thank you very much.
Thank you, Kanji Kumar Wadia ji. Now I would request Mr. Vinod Patil from Aarti Industries. He has been experiencing this technology for last more than 1 year on using Flexsim flow meter for measurement of compressed air. So what are your views, Mr. Vinod Patil?
Yes, Prashant. So not 1 year, it's since 2 years. So we installed the two, we have total two installations. So one is for the inline. We replaced the inline to the non-contact type. That is for the concentrated SO3. So here we are facing the problem of accuracy as well as the maintenance perspective. So there are a lot of challenges. So we overcome all the challenges with the non-contact type. So post installation, as such, there is no issue, and measurement accuracy is also maintained. So we are come out from all the worries. And the second is a portable type. So that we are utilizing for the verification of the process parameters. So which is used to enhance our processes for online measurement. So that is through the portable, we are verifying the exact process parameters and where the exact process is deviated. So that we are analyzing through that portable clamp-on flow meter. So we are also utilizing that same flow meter for the energy conservation perspective. So for the measurement of cooling water and pump discharges, so there we got a lot of benefit to these flow meters. Yeah, Prashant.
And are you happy? And is it serving your purpose, sir?
Yes, yes, perfectly.
Okay. I come to Mr. Mahesh Patil, DFPCL, and my concern or my question to him would be with respect to the clamp-on concentration transmitter, and how do you evaluate the benefits of having real-time nitric acid concentration readings against the previous 12-hour laboratory sampling procedure? And could you reach your target, and how can the benefit be quantified? So over to Mr. Mahesh Bhatt.
Yeah, Praveen. We are basically applied these meters in nitric acid concentration measurement, which is a raw material for our fertilizer plant. Earlier, we used to do sample analysis at every 12 hours, and we used to apply the correction factors for calculating specific consumptions in control system. So this was the earlier this thing, and after getting this real-time concentration measurement, accuracy of specific measurements has been increased, and lab analysis, of course, that has also been decreased, and we have reduced sampling frequency, means we are not cross-checking that samples again, because we are getting real time flow meter concentration readings. And earlier, in between this sampling period, there was an unaccounted variations in concentration, which were leading to specific totalization, incorrect specific totalizations, and
Maheshji, we can't hear you. We have lost his video as well as audio.
for our batch process, where we are using this meter for preparing a strong nitric acid batch. We were dependent on lab analysis to release the batch. And after installation of this meter, we are having real-time concentration readings available during the batch process itself. And the time of this batch process has been reduced drastically with this. And of course, the accuracy and quality of the batch is also improved. Yeah, that's all.
Thank you, Maheshji. Vivekji, how has been your experience of using clamp-on flow meter in your company, and what has been your experience in terms of maintenance, reliability, and safety?
Yeah, Praveen, at DCM Shriram, as I was explaining previously, we had installed actually one clamp-on type flow meter in the cooling water line in our 66 megawatt power plant, and that was actually a very big line of carbon steel of 1800 MB and 10 mm thick line. So there, instead of going for a different type of measurement like petrochemical or something like that, we had installed in January 2020, and till date it's working satisfactorily, except that where you put a sensor outside the pipe, there you have to sometimes use that coupling fluid, so that if there is any variation in the flow measurements, if the plant reports that these readings are not looking good. So that also we have done just after 14 or 15 months. So I feel we are getting a good, and because actually it is a non-contact type, and acoustically transmissive pipes is there, CS pipe is there. And what the beauty of this system was, because this was such a big line which is underground. So with this clamp-on type, we get one advantage, that even we can put the sensors on one side of the pipe. Means it's not essential that we have an access to the pipe from both the sides. So we have installed the sensor on the one side, and we have the access to that. And the flow range is also quite wonderful. It is up to 15,000 meter cube per hour of water. This is one application which is working perfectly fine at power plant. And the other two applications which I am going to share is the lubricating oil for cooling. And that pipeline is very small. It's only a 3x4 inch pipeline. And this we have recently commissioned yesterday only. And the beauty of this thing was, once we talk about flow meter, means we think of 4 to 20 milliamps output. That is something which we are going to take to DCS. But this particular clamp-on meter which we have installed has got a digital output also. So, and the indication is available in the field itself. Sometimes the operators, when they go for this lubricating oil cooling arrangement in the field, in the control room, people are able to see, but in the field also, the field operators are also very easily able to see and find out if there is a relay contact. The relay contact will come when the flow has gone low. Earlier, we had installed a flow switch, and each of us is very well aware that the flow switches are prone to failures, sometimes because of impurities, sometimes because of the mechanical kind of contact. So we had installed this clamp on, and I feel that I cannot say a good experience so far, but I feel that this will work good, and it will specifically give us a good reading as far as the oil flow, whether it is proper or not, number one, and immediate attention to the control room operator to take the needful corrective action. So these are the things as of time we have installed at the Shriram program. Yes,
Thank you, Vivek ji. Now I come to Mr. R.S. Rajan for the second track, the last speaker. And if he can talk about any bad experience of ultrasonic or any other technology in terms of flow measurement and what is the likely solution that you are looking for. So over to Mr. Rajan.
Yeah, ours is a chemical manufacturing company. We are using different types of flow meters. That is a differential pressure, it's an orifice type, variable area flow meter, magnetic flow meters, vortex flow meters, mass flow meters, etc. Even though it is meeting the requirement, and it is considered based on the application and cost effectiveness, we have deploying the flow meter on the particular application. Although these meters are working satisfactorily, certain flow meters give the difficult some problems we are facing also. It is due to the present. If you take the case of variable flow, variable area flow meter, sometimes some sticky particles. It is that is stuck up in the fixed position and gives a constant reading. There is no variation in the reading we are noticing. So if you notice that one, we have to stop it, we have to open it, and we have to flush it, and we have to take the maintenance. We are incurring downtime. Same thing for the vortex flow meter. If we take this one at the elevated temperature, we are facing the problem. It is in the mass flow meters, we are a vibrating tube is diameter is very small. There are chances of scaling inside and vibrating tube, the tube depending on the nature of the service fluid. If we take the, we are having ultrasonic type flow meter, non-intrusive type. That is a portable type that we are using it for the cross-checking of the flow reading at a different application of water. Mainly at the cooling tower outlet, cooling tower circulation pump outlet, and to more also we are from the GADC, but the Gujarat, when you are receiving the water from the Gujarat government, in that in order to monitor the quantity, that we are cross-checking with the air flow meter. Sometimes this ultrasonic meter does not work properly due to the uneven outer surface of the pipeline, scaling inside the pipeline, and the unavailability of straight length required for proper functioning of the ultrasonic flow meters. The main things we are looking for as a solution, we want to have a non-intrusive type flow meter we are required that is free from above mentioned limitations and to work on uneven outer surface, scale in any scaling, work on the scaling inside the pipeline and unavailability of any straight line requirement, and which can be used for any liquid, gas and steam without pressure and temperature limitation. That is what we expect to have a flow meter to measure in our unit. That's all.
Thank you, Rajan ji. I think the question to again to Mr. Matthias Gale is what are the critical limitations of the clamp-on ultrasonic technology versus typical misconceptions that you see in the market with respect to scaling? He was also talking, Mr. Rajan was also talking about it. Low pressure gas applications, concentration only on binary mixtures, or it is just a flow. So I request if you can give a short answer, because we need to take up the third track and also your presentation. So over to Mr. Matthias Gale.
Thank you so much. Okay, I'm gonna make it really short, and I hope I can answer some of the questions from the Q&A already with that. So 3 limitations that we really have to look into when dealing with the clamp on ultrasonic measurement is first of all, definitely inflow conditions, right? We need a certain length of straight line before we can install the meter. The theory says it should be 10 times the diameter of the instrument. Of course, with flow profile corrections that we have in our instrument, there are things possible to adjust here. And you might say, oh, this is a long distance, but keep in mind, you're very flexible with a clamp on flow meter, right? You're not limited to certain installation points. You can use any pipe in your factory. So yes, there is a limitation, but very often it's an easy one to solve. Second part is, can I also measure if there are solids or gas in my liquid? How does that work? If we would only offer the standard transit time method that most other clamp-on instruments use on the market, then yes, there is a certain limitation. We say around 10% of solids and gas. But Flexsim, as the technology leader, has developed other measurement technologies also based on the sound, on the ultrasonic, noise track, CFM, and so on, that then the instrument can switch on when certain solid or gas contents are met in the liquid, and then can mitigate those effects and cover a way wider range than you would normally expect from a clamp-on meter. The other typical limitation goes towards gases. Gases are brilliant isolators, right? And this is true for heat transfer, this is true for electric transfer, and this is also true for sound waves, right? Because in the end, we're sending sound waves through the gas. So depending on the gas, there needs to be a minimum pressure that it's actually acoustically conductible, right? If we're talking about, let's say, chlorine gas, it's something around 6 bar, depending on the pipe size. For hydrogen, it's more like 9 bars. If we go to high pressure air, it's 1 bar already. So it depending on your gas, we need then to talk about exactly what pressures can be measured. So these are really limitations. When it comes to misconceptions, one big misconception is around scaling, because a lot of people say like, yeah, but you're outside of the pipe, and what happens if the inside of my pipe changes, if there is corrosion or if there is scaling building? There we have to differentiate. So there is what I say is scaling, and there is clogging. If there is clogging and half of your pipe diameter is full of product, that impacts any measurement technology, and also our measurement will be affected. The good thing is, if you have to clean the pipe, no problem. If you have to throw away the pipe, no problem. You can still use our instrument on a new pipe. If there is just scaling, so we're talking about a couple of millimeters growth or a little bit of erosion on the pipe, that doesn't really impact our technology much. So it's a big differentiation to inline technology. Of course, people often say like, oh, it's not robust, right? This is just clamp on. For those of you who have the possibility, once we have exhibitions again, to actually see our instruments, this is like 3 to 4 kilos of robust stainless steel that goes like with huge straps that you clamp onto this the pipe. You should not, but you could step on it and would not move the sensors once properly installed. So that is actually not a concern there. And the last thing is something that is very unique to Flexsim is, with our clamp-on meters, we are not only measuring the flow, we can also measure density and concentration. So that's something normally not associated with clamp-on flow meters, because normally clamp-on flow meters as flow. And if I want to have a mass flow, I need to multiply it with a fixed density. In our case, we can actually measure the density. And given the time constraints, I want to show you 2 slides just to illustrate how this is done. I hope I can just simply, yes, I can share my screen.
Okay, please go ahead.
And I hope you can all see it.
Yes, yes, we can see.
Perfect. What we do here is we use the sound speed measurement, right? Because sound speed is just like we would know density, refractive index, conductivity, viscosity. It's a basic property of any substance. And so the sound speed of a medium relates to its concentration, can be related to its density. How we measure the sound speed is, in theory, very simple. In practice, obviously, there's a lot of calculation software and electronic hardware involved. But the theory is quite straightforward. We have here 2 sensors installed on the pipe. They send a signal back and forth, just like my colleague explained. And what we do is we measure this time already for the flow measurement. And then if we divide this time by 2, we have the average traveling time. And we know, we know the geometry of the pipe. We know the distance between the sensors, so we can calculate in the triangle the distance traveled by the sound signal. So we have a distance, we can divide it by a time, we have a sound speed. And then what we do is the sound speed is like, to give you a very rough idea here, where typically certain substances have the sound speed. So caustic soda is up here at 2,000, 2,500 or even more meters per second, right? That's how we measure the sound speed. Water would be normally at 20 degrees Celsius around 1,500 meters per second. And then if we look at acids like sulfuric acid, nitric acid, and so on, all of this is then below water. And so as we can maybe see quickly here at the example of the nitric acid, we have here the sound speed, we have here the concentration, and we can see that with the changing concentration, the sound speed changes. And we use this together with a temperature measurement, which can also be done clamp on, or we can integrate the temperature measure you have on site. And then we can calculate the concentration, the density, the mass flow, whatever, the mole weight, whatever is required on your end. And for those of you who have asked questions about like, oh, how accurate this can be, if we're talking about flow, and we're always around the ±1% in volumetric flow here. And then when it comes to the density measurement, it really depends on the substance. High concentration nitric acid, so starting at 60%, that can be measured really, really accurately here. Like you can see here how accurate this can be. If we go lower in the concentration, then the accuracy, we lose a bit of accuracy. So this changes a little bit depending on the substance and depending on the concentration of the substance itself. So this is how Flexsim actually provides real mass flow meter, real clamp-on mass flow meters, which a lot of the esteemed colleagues here in the panel already using. Of course, there is one, when it comes to the mass flow, there is one limitation here. It needs to be a binary fluid. So water and another chemical dissolved in it, because we need to go via the sound speed to calculate the density. But especially for acids and so on, this is a brilliant solution to make things safer and reduce your investment costs. So I stop here. There would be way more to say, but given the time constraints, I will stop the presentation here.
Matthias, I will, sorry, Praveen, just a minute. Matthias, I will just interrupt you if you can speak just for half a minute about calibration. Because whenever the instrumentation comes, the questions come, how frequent it has to be calibrated. So is there any method of calibration of such clamp-on measurement kind of instruments.
And
Yes.
one more addition is with respect to different fluids, will you calibrate it differently, or how is it that you go about doing it?
So when we talk about calibration here, we need to look at two different calibrations. One is the flow calibration. The instruments come calibrated from us in-house, and once they're installed, the flow doesn't need recalibration. The only thing is, I think what you were mentioning, Mr. Gupta, is to look that the sensors still have a good contact, to look yearly, half yearly, if your pipes are changing, if there's a lot of corrosion going on, if there's a lot of scaling up building, is to look at the diagnostics values and to see, like, is everything still good? I mean, it's very easy. You go on the instrument, you click through the panel, and you already see quality. That's one thing the instrument tells you, quality of the measurement, and as long as the quality is good, it's fine for the flow measurement. Now, with regards to, let's call it the density measurement, that's a different topic. The density measurement, we will install the instrument, or the instrument will be installed, and then it needs to be one-time field calibrated. So meaning from your laboratory, or because from your supplier, or wherever you get this number, you will tell us one time, what are we measuring right now? Is this 90%? Is it 90.5%? So we can set the instrument correctly. The reason is that, as I explained here, we need to calculate L, the distance, and this is very dependent on the exact geometry. And it's easier to do it this way around than to really measure every teeny tiny part of a millimeter around the pipe. So this has to be done a field calibration, and then you're good. Obviously, as with all analytical devices, it's always a good idea to at least yearly go do a lab test, compare the lab test to your field reading, and see if things are still moving smoothly. But I think that's just good practice in regards to all analytical devices. But we have instruments, they're running 20 years now, and customers haven't touched them in sulfuric acid plants, in oleum plants, and chloralkali electrolysis, you name it. Yeah.
Thank you, Matthias, and good that you were able to club your presentation also, and you have tried to answer some of the questions which are there in the Q&A window. Thank you for that, of utilizing the time perfectly. We have already reached 16:30. We have one more track to go and another 25 questions to answer. So I will request everybody to be sweet, if you can be very short. So my third track is on maintenance, replacement, and accuracy. And my question to Mr. Rajan would be, what is your company's best practice on replacing such instruments when corroded? And how do you ensure that lessons are learned from limited, suitable material selection? So over to Mr. Rajan, R.S. Rajan.
हे दाखव नंबर असेट नंबर पण कशासाठी लॅपटॉपसाठी
ते ऍक्च्युली या नंबरचा असेट तुमच्याकडे इनकेस हा लॅपटॉप ते फायनान्स अकाउंट वाल्याने किंवा अदर डिपार्टमेंटला आयटी डिपार्टमेंट वगैरे ते लगेच स्कॅन केलं की
Mr. R.S. Rajan, can you hear me?
Can you hear me?
Yeah, please go ahead, sir.
Because we are selecting the MOC of the material based on the wetting fluid during the project stage itself. We are selecting the MOC of the.
कोड आहे का त्याच्यामध्ये 10217 आहे माझा एम्प्लॉय कोड प्रमाणे
नाही एम्प्लॉय कोड
Hello?
Yes, sir, we can hear you. Please go ahead.
Listen, though sometimes the cost of the flow meter is also a little higher because of the selected method towards MOC, but in due course of time, the selection of most compatible MOC proves cost effective to the company. Considering the downtime and replacement costs, we are selecting the little cost effective material, the costly MOC also we are selecting it. In addition to the proper selection of the flow meter to ensure long life and proper functioning of the flow meters. A preventive maintenance schedule also we are following it. In our company, we follow preventive maintenance schedule as a standard rule. During preventive maintenance, to avoid leakages from the flanges, gaskets need to be replaced, which we ensure with the proper work permit from the process. During preventive maintenance, if corrosion is observed on wetted parts, if the proper approval is taken from the user department, and we change the upgraded version of the MOC. That is what the practice we are adopting in our company. So, okay, I believe.
Vivekji, if you can talk about the uncertainty requirement for non-critical control applications with respect to cooling water or steam flow control. So how are you managing it, Vivekji?
See,
short answer, sir.
Yeah. Very short and sweet. See, Mr. Rajan has already told you the same thing applies over here. Whatever flow measurements we are doing, number one, we have to ensure that there is no leakages from either of the tappings. Number two, there should be no choking in the tappings which we are taking. And number three is the preventive maintenance of these instruments have to be taken, because some of them, like I was telling you, in the clamp on flow meter, there is a signal strength. If the signal strength has gone below 60 dB, it means there is something wrong with the sensor. So that needs to be checked, and that is what I was telling you in my previous answers to your questions, that there were some complaints, and then we found that the signal strength has gone below 60 dB. So these are the things which we are following, but certainly as of time, other than cooling water, as of time, we are not measuring the steam flow through clamp on. It is only with the use of either the flow nozzles or the orifice plate with the DP transmitter. But certainly with this knowledge sharing session, I think we will plan in future for some of the corrosive fluids to put a clamp on for the better optimization of the plant. Thank you.
Thank you, Vivekji. Before we move to Mahesh Patil, Vinod Patil ji, and Kanji Kumar Wadia ji, I had two set of questions which I need to ask the delegates. And I would request them to please type in your answers in the chat window. What is the maximum measuring temperature? I think it was there in Ingo Nickel presentation. So my question is, what is the maximum measuring temperature? And the last question I will ask once I'm through with this panel. So I request Mr. Mahesh Patil, General Manager, DFPCL. How strong is the cost pressure to optimize instrument selections and warehouse routines? So over to Mr. Mahesh Patil.
Yeah, actually, every complex are having different type of flow metering instruments depending on the applications, services, and availability of space, or we can say the application requirement and philosophy, control philosophy. So as Gupta sir already said, the calibration and validation is a vital requirement for critical process control instruments. So calibration cost is one of the factor which comes in this maintenance and or we can say selection of instrument, then removal of that instrument from the line, and this can be of course done during the process shutdown period, or that particular line has to be shut down and we have to remove the flow meter. So that cost, removal box of cost, that cost is also involved in this. And the applications which are highly corrosive, toxic, abrasive, in that services meters are subject to wear and tear. So in such cases, one need to have in inventory the spare meters, or we can say transmitter or electronics, or the recommended spare parts which are suggested by the OEM. So that one again give rise to inventory cost, maintaining the inventory for the critical spare parts of flow meters. Then if we talk about differential pressure type measuring instruments which are having larger installation base in any industry, in such case we need to maintain the primary elements, because the primary elements in this differential pressure type flow measuring techniques are subject to wear and tear, and they need replacement at certain frequent intervals. Then the associated impulse tubings, pipings and fittings, all these are have to maintain in stock. If pressure and temperature compensation is involved in this kind of flow measurement techniques, then we do have to maintain the pressure, temperature transmitters, then sensors as well in stock. So these are some of the factors which are associated with various types of flow meters, which are having cost impact and inventory cost as well.
Thank you, Maheshji. Let me ask Mr. Vinod Patil from Aarti Industries. How do you evaluate the real cost of inline equipment replacement, including production downtime and manpower for pipe blocking and bleeding, flushing and cleaning, as well as arranging the actual hot pipe modification work? So over to Mr. Vinod.
Yeah, perfectly said, Prashant. So our policies at Aarti are also supportive for the procurement. So basically, we don't have the budget for the safety. So that is supports for the calculating the life cycle cost of any instrument. So our purchasing practices are also includes the total cost of ownership, which includes from purchasing to the disposal of the device. So on that basis, we are purchasing the device. So here it includes all the hidden cost, that is the replacement cost, inline modification cost, then productivity losses, everything it includes. So based on that, we are considering the total cost of ownership, and that is the key parameter for the selecting of any device. And with respect to maintenance or pipeline modification or the hot work requires, so definitely yes. So it requires for the inline instruments, but it is not required for the non-contact devices. And this is very supportive with respect to the safety. So we at Aarti very cautious about the safety, and this is a very good solution for us in our processes. Yeah, Prashant.
Thank you, Vinodji. Before I talk to Mr. Kanji Kumar Wadia, let me take the final quiz question. And this is very simple. Please type your answers in the chat window. What is the minimum amount of transducers required? I repeat, what is the minimum amount of transducers required? I request all delegates to please stay on. We will announce the winners shortly. My team at the back end is evaluating all the answers, and they will come back to you. Now I come back to Mr. Kanji Kumar Wadia from Naveen Flooring, and my simple question to you, sir, is how important is the total cost of ownership versus initial purchasing cost in your buying decisions for the metering part of it? So over to Mr. Kanji Kumar Wadia.
Yeah, good evening, sir. Initial cost was high, as compared, everyone knows, but with respect to other meters also it is not so high. And by installing this meter, we are taking the ownership, hence we have reduced our sampling frequency, which has saved our cost for the sampling procedures. By reducing sampling frequency, we are also reducing our manpower, man hours. And by having a good reliability and good repeatability and drift-free operation, we are also in line with the process 24 hours by 7. Hence, the ownership cost is very, very, very less with respect to the initial cost which we have paid. Thank you very much.
And do you see the possibility of steam measurement with clamp-on ultrasonic meter fit into your industry?
Yes, looking to the pressure and temperature, we have only 10 bar pressure over here, so we can think of it, and we don't mind in setting these clamp-on meters in our industry.
So let me now come back to, after hearing all the speakers, let me get Dr. Ingo Nickel, who gave his initial presentation, and I would request him to give the final thoughts on the third track, which in terms of non-intrusive flow measurement, how easy or difficult to install, how is it to with a limited straight length considering the limited footprints available in chemical plants, while ultrasonic technology needs enough straight length upstream and downstream for fully developed flow profile. And how easy it is to maintain or replace, and what is the accuracy level, because there are a lot of questions on the accuracy level with respect to pressure, temperature, and type of medium in the pipe. So I would request sir to give a short answer, and I see 27 questions, so would request Dr. Ingo Nickel for his remarks, final remarks, and after that we will take the Q&A.
Okay, yeah, I think my colleague Matthias already answered the question regarding the inlet lengths. Of course, it might be a limitation for clamp-on flow meters, but of course, it is most important that the measuring point is chosen at a sufficient distance from any disturbance, and only under this, then it can be assumed that the complete flow profile is fully developed. Of course, this means you have some limitation of placing your clamp-on flow meter in the plant, but due to the fact that we are not really, in principle you can choose any kind of place in the plant to clamp on. But if it's not possible, then we have also in our transmitters algorithm included, which can be used for not ideal inflow conditions, and this is called the flow profile correction. And there we have different versions, which also includes a disturbance correction mode, and this was developed with here in German, our National Metrology Institute, the PTB. There we did a lot of thousands of measurements, and then with these measurements we are building a new profile correction algorithm, which is included in our transmitters, and this helps us to also to use our equipment under not ideal conditions. Other question: how easy is to maintain and replace our flow meters? As I mentioned, it's almost a complete maintenance-free technology. This means if you install it once, then it runs for years, and you do not have to replace any kind of coupling pads. If the installation is finalized and all running, all parts are running well, then you do not have to make any kind of maintenance. In case of any failure of the transducers, you just have to replace the transducers. You mount some new transducers on the pipe, and then the complete measuring system can be used again. I think I already mentioned the application range for our equipment. Of course, the pressure is only important for gas measurement. There we need a certain amount of pressure of the fluid to get a good measurement. But for fluids, we don't have any minimum pressure limitations. Regarding temperature, I mentioned that we can cover from -200 up to 600 degrees Celsius, and also a lot of different pipe material. I think we already answered a lot of questions in the Q&A session. Maybe we can select one of the Q&A session to answer right now.
Okay. So now let me take the Q&A part of it. The first from Ashish Garg is couplant is the thing which is required for continuous measurement. Is there any plan for replacing couplant? Dr. Ingo Nickel.
No, as I've mentioned, if the installation is done well, then you don't have to the need for replace any coupling pads. It's installed once, and then it can be used for several times.
Vihan Shah is Naira Energy, Reliance, Sadani, SRF, Deepak Phenolics are my regular customers from oil and gas. Could you please specify some applications where I can pitch Flexsim products to the above customer group? I think this was already talked in detail by both our presenter from Matthias Gale as well as Ingo Nickel. Shall we move from this?
Yes, yes, please.
Does the MOC of the, Sivnath is talking about, does the MOC of the pipeline play a role in the calibration of the meter? So there was a question from Mr. Vinod Patil about MOC. So he's just asking, does the MOC of the pipeline play a role in the calibration of the meter?
Well, and in principle, we are calibrating our devices in our headquarters. The transducers are just calibrated, and if we go into the field for normal flow measurement, then the system will be not calibrated anymore, because we are using internally temperature probes to get the temperature on the pipe, and to make an online compensation, and calibration is not necessary. But of course, the piping material have an effect, but in principle, we can cover stainless steel, polymer piping. There we do not have many limitations.
Mr. Ashish Garg is talking about what is the maximum thickness of pipe where UCFM works.
Yes, I showed in my example.
Talked about the thickness part of it. So if you can elaborate on that.
Yes, as I've mentioned in my LDP, my example about the high pressure part in my presentation about the LDP process, you see that there's strong pipes with a very high wall thickness is required, and also for those very depending conditions, we can using our clamp-on technology. It's a little bit, it depends on the pipe diameter, but of course, if it's too thick, then we have problems to get the signals into the media, and it gets too much noise. But this depends also from the size and the dimension of the pipe inner diameter.
Matthias, what is the effect of viscosity? The question is from Surya Narayan.
So viscosity changes the flow profile, and that can impact for clamp-on meters the accuracy of the flow measurement. One of the big things about our meters is that when you do the installation of the meter, you can tell the meter there's a huge library of substances in it, and you can select your substance, you can select the concentration of your substance, and if it's not there and you know the viscosity of your medium, you just simply put the viscosity of your medium, you put it in there, and then our meters automatically correct for the viscosity impact on the flow profile.
Surinder Singh is talking about, is it applicable for catalyst slurry?
For
slurry, is it applicable for slurry part, catalyst slurry?
Yes. So we measure slurries. Then normally we use not transit time, but the noise track method to measure. That goes a little bit beyond the scope now to explain how that works. But yes, there are solutions that are suitable for slurry as well. But slurry is challenging. But that's a good thing about clamp-on flow meters. They're easy to test, right? Our colleagues in India can come over, can test it, and see if it works on that kind of slurry.
Hemant Avahad talks about external factors affecting sound wave. You talked about in the presentation. So, in terms of accuracy, what are the factors which will affect the sound waves?
So the main thing that would affect sound waves is if there is a pump, something that brings vibration into the pipe. That could impact things. Anything from the outside, everything that goes through the air is an amazing isolator when it comes to sound speed, will not impact the pipe or will impact our instrument. And if we have conditions, there is a damping material that we just wrap around the pipe, and then we can keep this pump problematic out.
You can type in your questions. We will definitely answer all of them because these are very short answers to be given. So please type in your questions. Don't worry about it. Arun Gupta is talking about, can we use clamp-on or inline ultrasonic flow meter for steam flow measurement? I think both the gentlemen talked about steam flow. I would request Dr. Ingo Nickel if you can take this question.
Yes, of course. As I mentioned, we are the only supplier who can use clamp-on flow meter for steam measurement, for low temperature and high temperature steam. I think another question came up in the FAQ in the Q&A session. What about wet steam? In principle, we only can cover dry steam applications. If we have a lot of amount of water inside, then our measurement will not work.
And there is another question: Are you Are you also supply jacket type ultrasonic flow meters? Hiren Singh is talking about it.
No, well, if we have a high temperature application, then the complete pipe will insulate it, and also the transducers with the wave injector will be insulated to do not lose any heat on the measuring system.
Arun Gupta is talking about how it can overcome the measurement of condensate or wet steam.
Yeah, this was related to my answer to the steam question. Yeah, there's a limitation. Our system is only usable for dry steam. This means for high temperature steam applications and low temperature steam application where we have no amount of water inside. Condensate, I think. The question, what is the meaning of condensate in this way? We, of course, if you go into refineries, then we have also condensates, which we are measuring, and it depends on what's here is asking.
Let me take the last two questions because our speakers also need to go. Can we use the same transducer for liquid, gas, and slurry? Surinder Singh is talking about it.
No, we have dedicated transducers, which one version for which are predominantly used for liquids, and the other they're using a different design. They are used for gas applications.
And this is a very interesting question, and this would be the last one. Mr. Barahuddin Bharmal is talking about. I have a question. For example, we install this instrument over a new pipeline. With time passes, suppose a layer of oxide deposits over the pipeline. Will performance this instrument get affected by the layer of oxide deposition? So Matthias, if you can take this up.
So the answer is yes, it will get affected. The next question is, will this affect the accuracy of the reading? No. So if you get oxide deposits on the inside of the pipe, and let's say we're talking about, I hope you can all see my video. We're talking about this how do you say, in this size, right? In this relation of deposit. Yes, you will see an impact on the measurement in terms of that the quality rating of the measurement, as I was described earlier, will not look so pretty anymore. But will the measured value of the flow drift? No. So at some point, if you know we're going into the bigger ranges of deposits, and I tried to make this point quickly earlier, then yes. But then the instrument will also show you that there's a terrible quality right now of the measurement, and that will be your cue to either refit the installation, right? That's all that then has to be done, refit the installation, or to call Flexsim India, and they will help you to read.
And one addition is, does Flexsim offer wireless clamp on flow meter?
The question is, no. I'm not sure what was wireless is meant. We have what we call portable flow meters. So they run, I think it's about 12 hours on battery, right? So but of course there is a wire between the transducers that are on the pipe and the measurement device you're holding in your hand, right? But yes, we offer this. If this is your question, then we offer this, yes.
I think we have answered the majority of them. Some of them have got repeated, and I know that I have overshoot my time by another 25 minutes. Let me do the thanking part and conclude this session. Let me thank all the speakers and Mr. R.S. Rajan, Senior Vice President, Manufacturing, Make Money Fine Chem Limited, Mr. Vivek Gupta, Joint VP, Instrumentation and Digitalization, DCM Shriram Limited, Mr. Mahesh Patil, General Manager, Instrumentation, DFPCL, Deepak Fertilizers and Petrochemical Corporation Limited, Mr. Vinod Patil, General Manager, Electrical, Instrumentation and Civil Aarti Industries Limited, Mr. Kanji Kumar Wadia, Senior Engineer, Instrumentation, Naveen Fluorine Instrumentation Limited, Dr. Ingo Nickel, Head of Market Management for Chemical Industry, Flexsim GmbH, with Matthias Gale, Global Analytics Sales Manager, Flexsim GmbH. So let me thank our partner Flexsim for supporting this e-conference. I would request all delegates give their feedback in the chat window. 1 being the lowest and 5 being the highest. So if you can give your feedback, this will try to improve us. And I think thanks to all our speakers who gave enough time, not only about talking about the challenges, talking about what the problem areas are and how it can be rectified, but also trying to answer all your queries so that you are able to understand this new technology. Let me now announce the winners and also talk about the answers. Where is Flexsim headquarters located? The answer is Berlin, and this answer was given by Mr. Piyush Upadhyay. He's an engineer from Aarti Industries Limited. Then what is the meaning of Flexsim? It is flexible industry mesh technique. And this answer was given by Ravikant Rajput, Aarti Industries Limited. He's a deputy manager E&I there. So I'm seeing a lot of Aarti Industries people getting Amazon vouchers. Congratulations to them. What is the maximum measuring temperature? The answer is 600 degrees centigrade, and it is Alpesh Shavalia, DCM Shriram Alkali and Chemicals Limited. He is the deputy manager. Sir Vivekji, is he working with you?
No, he's at Bharuch.
Okay. So good, sir. Congratulations to your team. And what is the minimum amount of transducers? The answer is 2. And again, I see Aarti Industries, Mr. Sovit Tiwari, assistant manager, winning this Amazon voucher. So I would request all delegates to register for our mega summit that we are doing. This is the Nextgen Chemical and Petrochemical Summit 2021 to be held on October 7 and 8, 2 days. 9 sessions are we are planning. So need your support, help, and also I would request this is mainly for you all. So if you can register for the event, attend the event, take time out, that would be great for us. Let me once again thank all speakers, delegate, and ICN team members, and also Flexsim team for making this event e-conference a grand success. But thanking you once again. This is Praveen Prashant signing off to meet again on October 7, 8, 2021 at 10 a.m. Till then, take care, stay safe, goodbye, and namaste.